So here's a picture. What we have here is that you have wax on all these rods at the end of the rods. Okay. And one is brass, one is aluminum, one is iron, one is copper. Okay. And there's a burner here. So where will the wax melt the most? So this is a really simple demonstration that is done usually to show that heat passes through solids in a way which we call conduction. Okay. And a better conductor is the one that sends the heat fastest. So here's what happens. The match that you have, which is stuck to copper, this is the first one to fall. And then it's aluminum, then it's brass, then it's iron. So what does that show? It shows that, so let me give you the numbers. So copper is first, aluminum, this, and this. So this is how the matches fall. So what this is showing is that copper was able to transfer heat from this burner to this match really, really fast, faster than all three. And the reason for that is one, density of copper, two, the available electrons that it has, because those electrons get the energy, they transfer that energy. And those are the factors that affect how fast or slow heat is conducted in these solids. So metals have an added advantage that they have free electrons, and those electrons can carry energy and move from one point to another. But other than that, usually in solids, particles hit each other, they collide with each other. Obviously, that happens because particles are really close together and they're vibrating about their fixed positions. So when they do that, they transfer energy to each other. It's like a domino. So one domino hits the other one, that hits the next one, that hits the next one. So that domino effect of heat is actually done, and so heat is transferred. So the idea here is that there is a flow of heat or thermal energy from where there is high temperature to where there is low temperature. But the solid on its own is not moving. Density is a factor here because if particles are close together, then they have high density, so they're going to hit each other faster. So that's conduction, and it happens in solids. So we say conduction is when there are two things here. Number one, heat transfers from higher temperature to lower temperature. So that's one. And second, no movement of material happens. So copper rod is still going to be there. In fact, any copper atom is also not going to go from one point to another, but heat is. So it's like energy being transferred without movement of that matter overall. So this is conduction, and obviously it happens best in things that have high density and in which particles are moving or vibrating at least. So things like wood, they don't have it. Like particles are not vibrating as much. So that is why it's a bad conductor. So imagine you were going to compare brass with this thing. So let's suppose I have this another setup. So I have a piece of wood here and there's a piece of brass there. So the white paper that we have wrapped it up with, what happens? The paper on the side of the wood burns, but the paper on the side of the brass does not burn. And that's a really interesting phenomenon. The reason is that the moment this paper gets heat, that heat is absorbed by brass and brass takes the heat away from it. So from a place of high temperature over here to the end, which is at low temperature. So brass does it really fast, but wood does it really slow. So what happens is that on the wood side, paper catches fire because heat is not being taken away from it at a fast rate, so it catches fire. But in the case of brass, it doesn't happen. So paper burns on the right side. So do you understand why that is? It's because heat is taken away by the brass, but not by wood. It conducts it. So here's the thing. If you touch something, like obviously if you hold on to some ice, a piece of ice, and you hold it in your hand, you will feel cold. But that's not that your temperature, it's simply the idea that heat is going from your hand into the block of ice, and that flow is what you feel. Okay, so that is conduction again. Liquids don't conduct as fast. So for example, this is an interesting experiment that is done usually whenever this topic is taught. So what's happening here is that we have a block of ice here, and this is water. So we are assuming that because water has particles close together, water has a fairly low density, but still particles are close together. They're going to hit each other, and the heat is going to be transferred to the ice at the bottom. So if ice melts, that shows that ice has received heat through conduction. But what happens is that that isn't observed. And it shows that water is a very bad conductor. It doesn't transfer heat as easily through conduction because particles are not as close, or they're not hitting each other as frequently as we would want them. And instead, heat is used to increase the rate of evaporation and eventually boil the water at the top. So that is conduction. Where do we use it? We use conductors wherever we need heat to be transferred. So if you want to design a boiler, you will obviously make that boiler cylinder using a good conductor like metal. If you're trying to design a saucepan, tawa, you will use metal because they are good conductors. Obviously, aluminium is usually preferred because it's a very good conductor, but it has a low density, so it's lighter compared to iron or copper. Copper expensive zyada ho jata hai. But it helps us the best when we are talking about insulators. This idea. Yeah, aluminum is abundant. Yeah, that's also a factor. So the idea of using table mats that don't burn your hand or damage the table, that is because we have that thing is a bad conductor. Similarly, air is a really, really bad conductor. So that has helped humans and other animals contain the body heat. For example, if you're wearing a jacket and it's cold, so all you're doing is that you are trapping heat inside. You're trapping air inside that jacket, and that air is a bad conductor. So it doesn't transmit heat from your body to the outside. So it's a bad conductor. We use quilts for that because they have this air space in which you can take that. Similarly, जो बहुत सारी buildings बनती हैं उनके बीच में वो क्या करते हैं कि एक cavity रख लेते हैं. So there's this wall and there's another wall and there's a cavity between them. So this wall and there's another wall and there is this cavity inside. So what happens is that if this was the room and this is the outside, so what happens is that because ये आपके पास वो bricks हैं, so heat from inside is slowed down when it's going out, and heat from the outside is slowed down when it's going in because you have trapped air in there. Okay. Sometimes people, instead of just using air, people also add stuff like chaff jo hoti hai wood ki ya kuch. Okay. So animals do it. They have fur, they have feathers, all of that because they want to trap air inside, and that air contains the body heat, doesn't allow it to go out. We use it like हम polystyrene foam use करते हैं, हम fiberglass use करते हैं ताकि because they're bad conductors, and usually we call all of this lagging. So for example, if I have something, let's suppose I have this metal and it is hot for some reason and I want to hold on to it and I want to make sure it stays hot for long. So usually आपकी diagrams इस तरह से करती हैं और उसको वो कहती हैं कि ये lagging है. This lagging is simply any bad conductor or an insulator that you have wrapped around this metal. तो ये lagging आप कोई भी hot water tank होगा उसके साथ आप रखोगे. Water pipes हैं, you don't want water to lose its temperature, तो उनको आप इससे करोगे. Insulated windows are amazing. Yes. So yeah, so that's the idea of where we use bad conductors. So understanding conduction is important for this. Metals का खास तौर पे फायदा ये है कि they have free electrons, so वो करते हैं. But there's another process which is convection. So ये convection होती है. So tell me what you notice or what you observe in this diagram. What can you tell me about convection?
It's when hot air, hot water, hot fluid rises and then cold fluid takes its place.
So ये बस आपने याद किया हुआ है ना, किसी ने आपको बताया हुआ और आपने याद किया हुआ, probably from grade 8. इस diagram के साथ इसको relate करोगे. grade 6 से अच्छा अच्छा it's taught in grade 6 okay कितने स्मार्ट होते हैं बच्चे हमारे
ग्रेड 6 में वो कन्वेंशनल करंट्स की थी ना जो अर्थ के नीचे होती हैं.
okay so what do you observe in this diagram बताएं ये बीकर में आपको क्या लग रहा है क्या हो क्या रहा है and why is the pattern like this so the first thing it shows is that there is this obviously it's probably KMNO4 or something let's just call it purple ink so this ink is going up okay and it's not spreading as much at the bottom right but when it goes up it spreads around much more so there's this whole cloud that is made on the top but not at the bottom and what does it show so there's this small flame that's making it do that so basically what's happening is that this small flame heats this small crystal that it's here and that crystal obviously it's dissolved in water or something so it goes up the water in there that has that crystal dissolved in it goes up why because it has a lower density so what does that mean that means particles are going further away if the particles go further away from each other they have low densities and yeah that doesn't surprise us because we know that liquid has particles that are relatively free so when you heat them up you're giving them more kinetic energy and when they have more kinetic energy they are going to move and when they're going to move they're going to obviously collide with each other move away from each other and in that way they are going to spread around so this spreading around reduces the density we also know the Archimedes principle that usually on in general things with high density sink and things with low density rise so that's exactly what's going to happen so the water at the bottom it's going to lose like its density is going to be reduced so it rises up and there the water at the top comes down so if there was a way to visualize the movement of these particles you can easily see okay there is going to form it is going to form a current that the low density thing will rise and the high density thing at the top will come down and then it gets heated up rises again by that time the thing at the top has lost its heat energy so comes down and eventually all of the temperature has increased so ये होती है convection that it happens in a fluid so that's the first thing the thing must be able to flow so it could be a liquid it could be a gas and what happens again is similar to the conduction so in conduction we said heat from higher temperature to low temperature but there's no movement of material now we're going to change that a little bit we're going to say that convection is when heat is transferred so convection is when heat is transferred from obviously high temperature to low temperature so that part remains the same low high to low yeah, that part remains the same but this time the material is also moving okay so by the movement of a fluid okay so that part is important and why does it happen why does the fluid move because if it has high temperature it has low density so it goes up and the thing at low temperature comes down because it has high density okay so where does it work the best weather it has convection currents in them हम घरों में भी यूज करते हैं इसको like if you had a heater the best spot what is ACS okay is that an organization ACS ACs air conditioners acha हाँ yeah they do set up a convection current so the best spot to so if this is a room the best spot to place an AC would be at the top and the best spot to place a heater would be at the bottom why justify these choices
Because warm air rises to the top, so the AC can cool the warm air. And there's cold air at the bottom, so the heater can warm the cold air.
very
There's no
good
point heating already warm air.
exactly so you want to have the maximum output of whatever machine you're using so the best thing to do that would be that heater works on the coldest things so they are going to be at the bottom so heater should be working on those similarly AC is going to work on the warmest part of the air which is going to be at the top so that is where it does that Yeah, so I'm not running both both of them at the same time. I'm just installing them both here. So we have to justify कहाँ install करना है इनको. Okay, where does convection happen naturally? So breeze. Maheen has, I think, the most experience amongst all of us. कि कहाँ पर ऐसे होता है? So the coastal breeze that you have.
Because I live in an apartment, तो यहाँ जब हवाएं आती हैं, you can it literally sounds like someone screaming, और खिड़कियाँ भी कभी-कभी हिलना शुरू हो जाती हैं. But over here, like the doors and the windows, वो ज़्यादा like thick से हैं, you know.
To withstand all that pressure.
Yeah, but it's really difficult to sleep जब रात को बारिश होती है.
अच्छा. Okay.
जब बहुत ऊंची आवाजें होती हैं, very high pitched, very loud, very irritating.
अच्छा, इतनी तेज हवा होती है.
जी.
अच्छा, so does it feel different during the day compared to at night? Because the direction of wind is affected by that.
So I haven't really noticed. Both are
Achha.
very not fun.
Yeah, not fun to होंगे obviously. Okay, so this is a
Sir,
diagram. I have.
Dina trigger हो गए हैं.
Yeah, I can see that. So this one, I've never really experienced this thing, so I can't really speak from experience, but मैंने भी किताबों में पढ़ा हुआ है कि there's this thing called sea breeze and there's this thing called land breeze. And we call it that because we are going to talk about कि हवा कहाँ से आ रही है. So basically sea breeze is that sea is cooler, land is warmer. So वो sea breeze sea to land आती है. And when I was a student, I was like, ये क्या हो रहा है? If that thing is cooler, so heat should transfer over there. So why is the air coming over here? So what do you guys think? Why is this opposite of the flow of heat? I don't know what monsoon rain wale scenes is.
So I think it's because the land loses heat faster.
Sure. So land has a higher heat, lower heat capacity, and sea has a higher heat capacity. Sure. And that is why sea is warmer at night and cooler during the day. क्योंकि वो absorb भी slow कर रहा है और lose भी slow कर रहा है. Sure, that has to do with heat capacity. But my question is, why is the direction of this breeze opposite to the direction of flow of heat?
जहाँ temperature high होता है वहाँ pressure कम होता है. So like wind goes from an area of higher pressure to an area of lower pressure.
So basically, it has to do with pressure. Yeah, this picture is a little inadequate. Basically, what happens here is that land is warmer, so the air here is also warmer. So this air rises up, and the air over here is coming to fill the vacuum here. Similarly, when the sea is warm, this air rises up. So the air at the land is coming here to fill the vacuum that is created. And that is the reason it flows. So how is it related to convection? Because ये जब ऊपर जाएगी ना तो ये ठंडी होकर वापस नीचे आएगी. ठीक है, और इस तरह एक flow चलता जाएगा. और यहाँ पे ऐसे flow चलता रहेगा. So it's basically a cycle that happens. I don't agree, Maheen. आप पता नहीं कौन सी superstitions में चली गई. Science पढ़ रहे हैं. Okay, so energy जो convection है ना, इसके दो main uses हैं. Number one is ventilation. घरों में जो भी हम करते हैं. So we have to take care of the ventilation. किस तरह से होगी? Air flows क्या होंगे when you're designing a house. Secondly, you need to know about the energy loss from buildings. के मतलब you don't want to spend too much money on designing and living in inefficient buildings. Unfortunately, that is the trend in Pakistan. Very few people actually invest or even think about making a house that is sustainable or has lower energy costs. यहाँ पे the processes that we do are like the standard process. They are really, really terrible. तो हर घर में हमें एसी चाहिए. बैठ नहीं सकते हम गर्मियों में, और सर्दियों में हम again हीटर के बगैर बैठना मुश्किल हो जाता है. Even though we live in a pretty developed region compared to the rest of the Pakistan. And the reason is simply we are copying and not designing our own. I first noticed this when I went to Shahi Kila, and I went to their basements, and they were so cool. Like they weren't cold, but they weren't warm, and they had sunlight coming in. And that was something that I was surprised with, because itna bada kila hai aur kaise design kiya. So I talked to the engineer over there, And they told me that these buildings are very well designed in that regard कि ventilation का, और वो कहते हैं कि मतलब वहाँ पे ना ऑफिसेज हैं उनके, जहाँ पे उनके तो ऑफिस जहाँ पे उनका रहने का इलाका था, मतलब मुगल्स जहाँ रहते थे। सो वो बता रहे थे कि शाम के वक्त यहाँ पर कमरों में हम दरवाजे अगर खोल देते हैं तो हवा चलती है, और पूरा जो फ्लोर है उस पर एक हवा का एक प्रॉपर चैनल बन जाता है, and it just flows, so it keeps it all cool. And that is something that they were doing 400 years back, but आज हम लोग करना इस पे सोचते भी नहीं. So that is a terrible thing, a terrible trend that we're having in this country, unfortunately. And all because making and designing these things require some money, they require some mental abilities, probably intelligence चाहिए होती है, and we don't want to pay architects around that. So that's something that we have to consider. The third process through which heat transfers is radiation. Uh, so radiation is when heat is transferred through electromagnetic waves. Okay, so that is again, so heat is transferred from one place to another. It doesn't mean that it has to go from hot to cold. Obviously, it has to go out of the hot thing. It just goes away from the hot thing that's emanating this, and it's through an electromagnetic wave that happens. So infrared waves are really mainly responsible for this. So this has to do with how fast or slow something absorbs that. So light colored clothes, light colored buildings, they are good at not absorbing it, but dark colors absorb it better. They are good emitters, they're good absorbers. So dark colors आप पहनोगे जब आपको heat absorb करना पसंद है, so that's probably in the winters. और हमारे जो cotton है या इस तरह के light colored clothes or light clothes, in fact, we wear them during the summer because they are bad absorbers, bad emitters. Okay. So another important thing here is the how polished or dull the surface is. So polished things जो हैं वो ज़्यादा emit करती हैं, और dull जो हैं वो ज़्यादा absorb ज़्यादा मतलब they're bad at this. So we use it whenever we are designing stuff that is we want to remove or minimize the effect of radiation. So वहाँ पे हम उसको colors को और उसको surfaces को rough या smooth करते हैं based on all this. Okay, so that is radiation and all that. अच्छा, एक बड़ी मजे की चीज़ है, the rate, how fast or slow something cools down, or the change in temperature is basically directly related to the ratio of area and volume. और ये बड़ी मजे की चीज़ है. So if something has a higher volume, then it loses heat faster. Okay, or so slower. And if something has a higher area, then surface area, so वहाँ से उसने heat को lose करना है. तो इसकी वजह से, so अगर आपके पास बड़ा क्यूब है ना आइस का, फॉर एग्जांपल, और आपके पास छोटा क्यूब है आइस का, so the ratio of the smaller one might be higher and the ratio of the larger one might be lower. तो इस वजह से वो जल्दी मेल्ट और स्लोली मेल्ट करने का चक्कर होता है. सो अगर आपके पास एक बड़ा आइस का ब्लॉक है वो बहुत स्लोली मेल्ट होगा, बट एक छोटा आइस का ब्लॉक बहुत जल्दी मेल्ट होगा, बिकॉज रेशियो ऑफ एरिया टू द वॉल्यूम it increases if you break it down into smaller pieces. So that's something that isn't in your syllabus, mind you, lekin I always found it really interesting, especially when I was studying about insects. For some reason there was this. So insects, for example, they have a really large surface area and they have very small volume. So unka area to volume ratio bahut zyada hota hai, which is why all insects need to first warm up and for them to function. So वो सारे cold blooded तो होते ही हैं, but उसकी मेजर रीजन ये भी है कि उनके एक्सोस्केलेटन्स का सरफेस एरिया इतना ज्यादा होता है और उनका ऑब्वियसली बॉडी तो बहुत थोड़ी सी होती है. So इस वजह से they lose temperature really fast. So no, I was just studying it out of interest. I was very fascinated by insects. So that's it.